Today's class we are going to start the new chapter which is periodic classification, right? So you may expect 1 to 2 questions from this chapter, and this chapter is very easy. Okay, the only thing you have to do is you should have a good clarity in the concept. Okay, because this is a theoretical chapter, you will get a theoretical question. If you have a good clarity with all the concepts of this chapter, then easily you can solve the questions. Okay, so it is discuss only important. Okay, this is a rapid revision classes, so we people are going to discuss only important topics. Okay, so the first topic is nothing but Doberener law of triad system. What is the meaning of triad here? Triad indicates what? Set of three elements. Okay. So generally, what does Doberener he did? He took help of what? He took help of atomic weight. Okay, he took help of atomic weight and tried to explain his ideas. Okay, he tried to explain his ideas regarding what? Regarding the periodic table. So what he says that according to this law, in a triad, the atomic weight of the middle element. Okay, what he says that in a triad system, triad means what? Set of three elements. Okay, the atomic weight of middle element is equal to average of atomic weight of first and third element. Okay, so that means, for example, if I take a triad system. Okay, here what is the triad system? Lithium, sodium, potassium. Okay, these three are what? Triad system. Okay, now what happened? As per law, what does the law says? If you take atomic weight, whose atomic weight? First one atomic weight and third one atomic weight. Okay, what is that? 7 plus 39. So if you take average of these two atomic weights, so how much you people are going to get the answer? 23 people are getting, and the obtained answer is nothing but similar to the atomic weight of the middle element. Okay, so what is the law they are saying? In a triad, the atomic weight of middle element is equal to average atomic weight of first and third element. Okay, average atomic weight of first and third element. Clear till here? Now in the examination point of view, what you in which model you may expect the question? So in the examination, what happened? They will give you some four options. Okay, they will provide the four options and ask you which of the following is eligible for triad system. Okay, which of the following is will not suitable for triad system? This model you make it. Okay, now what it will be very difficult to find out all the three weight, taking the average of the weight, then checking whether it's following or not. That will be very long process. Okay, now what we are going to do, we are going to learn a small trick how to identify whether the given three elements belong to triad or not. Okay, so what is that trick? The first point is what? Element must belongs to same group according to our modern periodic table. So whatever the three elements they will provide in the option, first of all, those three elements must belongs to same group. Okay, if any one element is also not present in that group, indicates what? The option is cancelled. Okay, next second important point is what? Difference between atomic number. Okay, you have to check the atomic number of two adjacent elements must be what? 8 comma 8 or 18 comma 18. Okay, so let us try to understand the first example. So in the first option, what they have given? Lithium, sodium, potassium. Okay, we have to check, we want to know that whether the given is what? Whether the given is eligible or not eligible. Okay, so what is the atomic number of lithium? 3. Atomic number of sodium? 11. Atomic number of potassium? 19. Okay, so now what is the difference between the atomic number? 11 minus 3, 8. 19 minus 11, 8. Can I say 8 comma 8 we people got? So 8 comma 8 indicates what? The given question is what? Eligible for the triad system. Okay, whereas for the second example, so what is the second example they have provided? Fluorine, chlorine, bromine. Okay, atomic number of fluorine 9, atomic number of chlorine 17, atomic number of bromine 35. Okay, so what you will get? 17 minus 9, 8, 35 minus 17, 18. So as I said, when you should say that the question is eligible for triad system, if the atomic number differences be 8 comma 8 or 18 comma 18. Okay, if you are not getting these two, other than if you are getting anything other than these two combination, indicates what? That is not eligible for the triad system. Okay, next to oxygen, sulfur, selenium. Can so all the three elements? Okay, you have to follow step by step. What is the first rule? All the three elements must belongs to same group. Okay, can I say here in the second example all three elements belongs to same group? Yes. What is the second condition? 8 comma 8 or 18 comma 18. Can I say the second condition is not satisfied here? So hence what you can say, the second fluorine, chlorine, bromine is not acting as what? Triad system. Okay, now you have to go with for next example, chlorine, bromine, iodine, and you have to find, and later when you find, you will get to know that this is a triad system. Okay, right. Second part, important point, which is nothing but Mendeleev's law of periodic table. So he also explained his ideas based on what? Based on the atomic weight of the element. So the most important thing is definition. Very, very important. Sometimes they will give the definition and ask you whether the definition is right or wrong. Okay. So what is the definition? The physical and chemical properties of elements are periodic functions of their atomic weight. Okay, very, very important. The last term is very important, for which like for which theory you will get atomic weight. What is that? Mendeleev's law of periodic table. Okay, now the question is, what is the exact meaning of periodic function here? So let us try to understand what is the meaning of periodic function. When the elements are arranged in the increasing order of their atomic weight, the elements which show similar property get repeated at regular interval. Okay, so the best example in our day-to-day life where you can see this periodic function. Okay, what is the meaning of periodic function? Okay, so the exact meaning of periodic function you will understand if I take a example which is in our day-to-day life, which is nothing but calendar. Okay, so when you see the calendar, you can see that there are total 7 days, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, after Saturday, what happened? Once again, Sunday is repeated. Then Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Once again, Sunday is going to be repeated. That means after particular 7 days, for every seventh day, what is happening there? That the day is repeating. Okay, so this repetition property, okay, this repetition of day, okay, the repetition of same Monday after 7 days. Okay, so 6 to 7 days. So what you are going to get, this property, repetition property, we should call it as a periodic function. Okay, in the calendar you can see that after Monday you will get Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. After every 6 days the same day is going to be repeated. Okay, so in the same way in the periodic table, when you arrange, okay, like the way in the calendar people arranged the days, right, in the periodic table if you arrange the elements with the increasing order of atomic weight, based on atomic weight, if you arrange the elements for after certain particular interval of time, what happens? Same property is repeated here. Okay, in calendar day is repeating, whereas in periodic table property is repeating. Okay, so this repeating property we should call it as what? A periodic function. Okay, right. So what is the specialty of Mendeleev's periodic table? The specialty of Mendeleev's periodic table is what? He is the one who first explained the arranged the elements in the form of tabular form. In the table you can see that columns and rows. Remember, columns are called groups, rows are called series. Now you will say that no ma'am, you are saying wrong, rows are nothing but periods. We generally we call it as a columns as a group, rows as a periods, right? But remember, the word period was given in which theory? The latest one, which is nothing but long form of periodic table. But in Mendeleev's periodic table he given the word what? Series. So series was used in which theory? Mendeleev's theory. Okay, so what happened while writing that periodic table? He left some gaps. Okay, thinking that in future you may get some other element discovered. Okay, so now what happened? What are those gaps? There are total 4 gaps. Very, very important. You may get a question on this. 4 gaps. Okay, so what are those 4 gaps? Eka boron, Eka aluminium, Eka silicon, Eka magnesium. Okay, first of all, what is the meaning of Eka boron? Eka boron means what, Nana? Gap is left after the boron. Eka aluminium means what? Gap is left after the aluminium. Eka silicon means what? Gap is left after the silicon. Okay, Eka manganese, what? Gap is left after the manganese. Okay, so based on this, Eka boron was later, after some discoveries, what happened? Whatever the gap which was there after the boron, that gap was filled with which element? Scandium. Aluminium, Eka aluminium is gallium, silicon germanium, manganese technetium. Okay, just try to remember how to remember this example. Just remember BSc. Okay, so B indicates what? Eka boron. SC indicate what? Scandium. So Eka boron is what? Scandium, because there will be sometimes you may get the match the following also. Okay, Eka boron, scandium. Next, man technetium. Just remember man technetium. Okay, technique, man technique. Generally, TC indicates what? Technetium, right? So man indicates what? Manganese. So manganese, technetium, boron, scandium. How to remember this? Eka boron, scandium, BSc. How to remember manganese, technetium, man technique. Okay, move to the next one. A for aluminium, A for here gallium. Okay, so what you can say? Eka aluminium, gallium, silicon, germanium. Okay, aluminium, gallium, silicon, germanium. Clearly here, in this way, in this manner, people can remember the formulas, everything. Okay, right. So examples. Move to the next type of periodic table, which is nothing but modern periodic table. Okay, so out of all, what is the first important periodic table? Which is nothing but triad system, Dobereiner, right? Dobereiner triad system. What is the specialty of Dobereiner triad system? When you arrange the elements x, y, z, okay, when you take average atomic weight of these two elements, its value will be equal to what? Middle one. Okay, but how to identify the triad system? How to identify the triad system? What is the first trick? Whatever, whenever all the three elements first of all belongs to what? Same group. Okay, what is the second condition? Their atomic number difference should be 8 comma 8, or it should be 18 comma 18. Then only you can say that the given example follows the triad system. After that, what is the second one we have learned? The second one is what? Mendeleev's periodic table. What is the specialty of Mendeleev's periodic table? He is the one who first explained the elements by using what? Tabular form. In his definition, the overall definition end with which word? Atomic weight. Okay, next in this Mendeleev periodic table he left some gaps. Okay, those gaps are total 4 gaps. Okay, remember Bse, Eka boron, scandium, man and technetium. That means manganese is technetium, aluminium, gallium. Next boron, germanium. Boron is there, right? No, no, not boron. Silicon. Eka silicon, germanium. Clear till here? Next, third one is what? Modern periodic table discovered by whom? Moseley's periodic table. His classification was based on what? His classification was based on atomic number. Okay. So what happened here? The physical and chemical properties of an element are periodic function of atomic number. Very, very important. So here the third one is what? The third one is modern periodic table discovered by whom? Moseley. Right. So what is the specialty of this? He explained his idea by taking help of what? Experiment. Okay. Now we are going to study the experiment, and later what happened? The overall whatever the definition is there. Okay. Definition part. Here definition part is ending with which word? Atomic number. Clear till here? Right. So what was that experiment? What he did? He just high speed of electrons was passed through the metal surface. So what happens? Some x-rays are reflected back. This x-rays has some frequency. Okay, so what does he says? He says that the frequency is directly proportional to whatever the frequency people are getting from the x-ray. That frequency is directly proportional to what? Atomic number of the metal surface. Okay, so this is the equation. Right, we are not going to get any numerical from this equation. Move to the next one, which is nothing but long form of periodic table, which is nothing but Bohr-Bury model. Okay, here also the definition just see the physical and chemical properties of an element are periodic function of their electronic configuration. Very, very important. Okay, so let me repeat you again. Right, so what is the definition? The physical and chemical properties of an element are periodic functions function of their dash. Okay, first option, if the whatever this here x is there, okay, if the x is atomic weight, okay, then the theory we should call it as what? Then the theory is called Mendeleev's periodic table. Okay, if it is ending with atomic number, if the x is nothing but atomic number, in that definition, if the x is atomic number, okay, then the what we should call the theory? Modern periodic table. Modern periodic table given by whom? Given by Moseley. Next, third one, if the x is nothing but electronic configuration, then the is called long form of periodic table. Long form of periodic table. Okay, just remember which one is, if I ask you out of three, which one is the latest one? So many people think that, ma'am, the word modern indicates latest. No, the long form of periodic table is what? Latest form of periodic table. So how to identify that the definition belongs to long form of periodic table? Can I say electronic configuration? What is electronic configuration? 1s2 2s2 2p6 3s2 3. That means it's very long, right? So that's why you can remember the trick. What is the trick? Electronic configuration is long, so hence it will come under what? Long form of periodic table. Clear till here? Right, so moving to the next one. So he classified in according to this modern periodic table, not modern, latest periodic table. Which one is the latest periodic table? Right, a long form of periodic table. Okay, so discovered by whom? Discovered by Bohr and Bury. Okay, so in this periodic table, what is the specialty? There are total vertical columns and horizontal okay, there are total vertical columns and horizontal rows. Okay, he says that the row is nothing but periods and columns are nothing but groups. So total how many groups we have? 18 groups. How many periods we have? 7 periods. Okay, how many blocks we have? 4 blocks. What are the left side? S block, right side P block, middle D block, bottom side F block. Clear till here? Now let us discuss about the groups. Very very important. You may expect one question from the group also. Okay, what they have given? Description of group. First group. Okay, first group. First group is also known as 1A group. Okay, we'll study opposite like a comparison. Second group is also known as what? 2A group. Okay, there are total how many groups? 18 groups. Out of that, we are going to study first one and second one. First one is also known as 1A. Second one is also known as 2A. Okay, 1A, what is the other name of 1A? Alkali metals. What is the other name of 2A? Alkaline earth metals. Okay, what is the electronic configuration? Ns1. Electronic configuration Ns2. These are metallic in nature. These are also metallic in nature. These are soft metal. These are also soft metal, but compared to 1A, these are little bit hard metals. Okay, move to the next one. When oxides of first elements dissolved in water, hydroxides are formed having basic nature. Here also oxides of the second group elements dissolved in water form basic nature. Okay, so first of all, what are the elements present in the group 1 and group 2? That is very very important. Okay, so let us try to write down what are the elements present in the group 1. Lithium, sodium, potassium, rubidium, cesium and francium. Here francium is what? Radioactive. What is the second group element? Beryllium, magnesium, calcium, strontium and barium. Okay, so these are the first group and second group elements. Okay, what is the specialty of first group? First group says that they have metals. Okay, second group will also says that they have the metals. They also having the metal. Then first group says that the oxides of their metal. What is the meaning of oxide? Lithium oxide, sodium oxide, potassium oxide. These are nothing but oxides of first group. Okay, when these oxides of first groups are taken and if you add in water, they will provide hydroxide. And what is the nature of hydroxide? Basic nature. In the same way, second group says that even second group has the oxide. What are the examples of second group oxides? Beryllium oxide, magnesium oxide, calcium oxide. Now what happened? When you take the oxides of second group and if you dissolve in water, you people are also going to get what? Hydroxide. And what is the nature of that hydroxide? Basic nature. Let us take example here. Can say this is nothing but sodium oxide, first group oxide. When first group oxide is dissolved in water, immediately what you are going to get? You are going to get one base here. In the same way, second group oxide when you take and dissolve in water, what you are going to get? Hydroxide, which is also basic in nature. But there is an exception in the second group. There is an exception in the second group. It is nothing but beryllium. Okay, beryllium is not an alkaline earth metal because it is not a metal. It is nothing but metalloid. What is the other name of metalloid? Semi metal and amphoteric. What is amphoteric here? The one which react with both acid and base is called amphoteric. So hence beryllium oxide is amphoteric, beryllium hydroxide is also amphoteric. So from this people have learned two important points. Okay, first of all, if I write first A elements, okay, then I'm going to write here second A elements. Okay, so what are the first A elements here? Lithium, sodium, potassium, rubidium, cesium. What are the second elements? Beryllium, magnesium, calcium, strontium, barium. Okay, if I say all first group metals, okay, if I say all first group metal, all first A elements are metal. So true or false means you should say true. Okay, next all second A group elements are metals. You should say, ma'am, it's false. Why all are not metal? Because exception is what? Beryllium. Except beryllium, remaining all are metals. Okay, beryllium is what? Beryllium is a metalloid. Okay, beryllium is a metalloid. What is the other name of metalloid? Semi metal. Okay, semi metal. So do you find any group which is purely made up of metal? What is the meaning of purely made up of metal? All elements should be metal. So which is that group? First A. Okay, second A group all are metals. No exception is what? Beryllium. Okay, right, move to the next one. Third group, 13th group and 14th group. Right, just now we have learned that first group. Right, group number 1 is also known as 1A group. Okay, group number 2 is also known as 2A group. In the same way, group 13, not 3, 13 is known as 3A group. Okay, Group 14 is known as 4A group. Okay, so what is group 13 here? Boron family. What is group 14 here? Carbon family. What is electronic configuration? NH2NP1. Electronic configuration NH2NP2. So the most important thing here, the best part, the thing which every student has to learn is the nature of the element. Okay, so what are the nature of element in the first group? All elements are metal. Okay, what is the nature of elements in the second group? All elements are metal except beryllium. What is the nature of metal? What is the nature of beryllium? Metalloid, or else you can say amphoteric. Coming to the 13th group, all elements are metal? No. So first one is what? Non-metal. Next, amphoteric. Next is what? Metal. First of all, people have to learn the sequence here. Okay, what is that sequence? Always remember, first category should be what? Non-metal. Second category should be what? Semi-metal. Third category should be what? Metal. Okay, so based on this we are going to learn few codes to remember the nature of element. What is that here? 113. Okay, and what about here? 122. Okay, for example, if I ask you, okay, if I ask you for group 13, what is the code? 122. For group 14, what is the code? Sorry, here 113, 122. Okay, so let us try to understand what is the meaning of 113. Okay, 113 indicates what? First of all, you have to write the elements. What are the elements of group 13? Boron, aluminium, gallium, indium, thallium. Okay, what is the 113 here? 113. Okay, as you people know the sequence, what is the first one? Non-metal, semi-metal, and metal. I hope you people are able to understand about the code. What is the code for group 14? 122. Group 14 elements are what? Carbon, okay, silicon, germanium, tin, and lead. Okay, so what is the code they have provided? 122. So 122. First one should be non-metal, second one should be semi, or which is nothing but amphoteric or metalloid, and third one is what? Metal. So like this, if you just remember the codes, okay, then it will be easy to remember the nature of the metal itself. Okay, first of all, in this chapter we are going to study only S block and P block. That is nothing but group number 1, okay, group number 2, group number 13, 1, 2, 13, 14, 15, 16, 17, and 18. Okay, there is no problem with 17 and 18, easy to remember. That I will explain. Okay, and there is no need of worrying about group 1 and group 2. That is also easy. Why? Because in group 1 all are metal. Okay, in group 2 except beryllium, remaining all are metals, right? In group 13, what is the code? 113. In group 14, what is the code? 122. That means you have to remember just the code of what? Group 15 and group 16. Okay, right, so let us try to understand here. Coming to the next one, group 15 and 16. What is the code for group 15 and 16? 221. Here also what? 221. So from this what you have learned? You have learned the code for 15 is what? 221, 221. Can you say reverse of group 14 is this one? 221, 221. Now let us try to understand what is the meaning of 221. What are the group 15? Group 15 is nothing but what? Nitrogen family. What are the elements? Nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, so what is the code? 221. What is the meaning of 221? 221. First one is non-metal, next is semi-metal, and last one is metal. So what is the nature of bismuth? Just try to write on the sequence and you will get the answer. Clear till here? I hope you people understood. Let us go for the next one, which is nothing but our group 17 and 18. So what is the specialty of group 17? Here all elements are non-metal. So group 17 specialty is what? It's a group is made up of what? All metals, non-metals. Do you have any group which is purely made up of metals? Yes. What is that? Group 1. Do you have any group which is purely made up of non-metals? Yes. What is that? Group 17. And you people know group 18 is inert gas. So the elements are highly inert nature. They are not going to show any chemical reaction. Hence they are gases. They don't have any metal, non-metal, semi-metal like that nature. Okay. Next, they exist in diatomic form. This one is very important because you people are going to, as you people know that, remember in the thermodynamics I said delta G naught formation is 0 for whom? For stable compounds. Even delta H naught F is also equal to for whom? Stable compounds. How to remember stable compounds of halogen? Fluorine, chlorine are gases, bromine is liquid, iodine is always solid. This part people have to Remember. Clear till here? Next one is what? 80. 80 indicates what? Astatine. So since it is a radioactive, we are not going to write in the halogens. Clear? Next one is D block. So when you should say that D block contain which group? Group number 3 to group number 12. Okay. Group number 2 is what? Group number 2 is 2A. Okay. Whereas group number 13 is what? 3A. That means group number 3 to 12 is what? D block. Electronic configuration is what? Outermost N minus 1 D 1 to 10, NS 1 to 2. Exception is what? Palladium. Okay. Why palladium is exception? Because it is not following the general electronic configuration. See here you can see that they said 1 to 10, 1 to 10. Here S should be what? Either 1 or 2. But you people got 0. So hence palladium is the exception for the D block electronic configuration. Now few students will say that ma'am we have learned that chromium is an exception. Okay, even if people studied that copper is an exception, then why are you not writing here copper and chromium? See, copper electronic configuration is what? Argon, okay, 4s1, 3d5, right? Copper is what? Argon, 4s1, 3d10. This is exceptional electronic configuration. But still, is it following the general electronic configuration? Yes, it's following the general electronic configuration. So palladium is an exception for what? The one who doesn't follow the electronic configuration. Whereas chromium copper is exception for what? They are not following the general trend of the electronic configuration. Clear till here? Right, move to the next one. F block. In the same way, F block also has one exception, which is nothing but thorium. You can see that it's not following the general electronic configuration. Clear till here? So remaining part we are going to discuss in the next class.